Here we go. We're on.
Okay, I would like to open tonight's August 7, 2020 Zoom virtual meeting of the North Shore Amateur Astronomy Club, a club which is dedicated to spreading the science and enjoyment of astronomy to the Merrimack Valley and beyond, and by far what is considered to be one of the best astronomy clubs in this price range. Okay, so I will click the gavel here, and I will declare the meeting open. Now, before we proceed to other orders of business, I would like to ask and acknowledge any visitors that we are privileged to have among us this evening.
I guess that would be myself.
Welcome.
My name is Scott Flagg, and we just moved here from Fort Myers, Florida.
I thought you were going to say Flagstaff. That would have really been good.
Flagstaff, no. They haven't been a long time since I've been a Flagstaff. I was in the astronomy club there at Southwest Florida Astronomical Society and also in the Everglades Society down there.
Wow. Okay.
And I'm a faculty instructor in cosmology at Florida Gulf Coast University. That is sort of my passion.
Right, well, let me clarify that. Is that cosmology or cosmetology?
Yeah.
Okay,
cosmology, yeah.
That's great. Thank you so much. We are delighted to have you here with us, and thank you so much for taking the time out of your day to join us. We really appreciate it.
Hey there.
Well, very.
It's the Hobbit. Okay.
Oh, there. Yep, I'm here.
Okay. Do we have any other visitors? Okay, I guess that's it for the visitors. Okay. Okay, so before getting into any other business, I want to establish that by acclamation, we have a quorum and that the meeting is official.
Sounds good.
Okay, so now that we have established that we have a quorum and the meeting is official, I would like to confirm that everyone has had a chance to read the minutes of our previous meeting, which were available to everyone to read online. And I would like to ask if there are any recommendations or omissions or additions to said minutes.
I think they were a fascinating read.
Okay, well, all right, do I have a second to the fascinating read motion by the Vice President?
Second.
Okay, I'm gonna, by acclamation, it was a fascinating read, and I'm going to accept them by acclamation as read. Okay, moving right along. Do we have a treasurer's report if appropriate?
Right at this time, not much has changed, so it's probably kind of a null and void thing right at the moment.
Okay, did we take advantage of the buying opportunity when the Dow went down to 18,000?
Sure.
Because I certainly did, and I made a killing. Okay.
Good for you.
That's good. Okay.
Only
Now,
doctors can do that.
Okay. Well, I just took everything in my 401k that was a bond and I turned it into stocks. Okay, great. All right, and so that you're supposed to take advantage of buying opportunities. Okay, now, okay, do we have any upcoming activities that anyone would like to mention?
Brewster wanted us to mention something, but I don't remember what. He sent out an email
Okay.
asking for volunteers, so everybody already knows about it anyway.
I think Brewster was interested in doing something for the upcoming meteor shower. Could that have been it?
Yes, that was it.
Okay. Does anybody have any comments about the upcoming meteor shower?
Comet litter. I don't understand the appeal.
No, comments, not comments. Comments about the upcoming meteor shower.
That's what meteors are, comet.
That's right. Okay, yeah, it's a little piece of a star or planet. Okay, good. All right. Okay, so that's the upcoming activities, I guess, is going to be that Brewster wants everybody to watch the meteor shower with him with social distancing, which I think would be wonderful. Okay, so let's go through the various reports. I see that Dennis is with us. Dennis, do we have anything from the Salem State Observatory to report?
Can you hear me okay?
Yes,
Yeah.
we can.
Okay. The only thing that we've got so far is we still don't have a reopening date. Luke and I have been discussing PPE equipment to protect ourselves and make rules for any guests that will come up once we reopen. And Luke is also putting in to try to get some grant money to purchase a 60mm solar telescope. But we don't have an opening date yet, so that's still up in the air.
Okay.
That's everything.
All right. Does anybody have any questions for Dennis? Okay, Dennis, thank you very much for your report. Okay. Okay, do we have anything from the observatory at Merrimack College? Guess not.
No.
Okay, are there any other reports from directors or committees that we should acknowledge at this time? How about star parties? That's pretty much a
Gone.
gone. Okay, fine. So
I
forget
think
about that.
he might still be planning the Battis Farm ones, but it's in September, which is a month, 2
Now,
months away.
is Battis Farm where he wanted to do the meteor shower from?
No.
No,
Okay.
you want to do that from the Goldberg Estates.
Oh,
Yeah.
the Goldberg? Okay, that's cool.
So he may or may not have I don't think they've heard whether they're going to even do the trails and sales this year or not because of social distancing, but he still got it on the list.
Okay.
I doubt if it'll happen.
All righty. Okay. All right. Moving on then. Is there any at this time old business for the club to address during this business meeting? Because there is some new business if there isn't any old business.
Why don't I make mine old business? Because it deals with an old issue.
All
And
right,
then you
please
have
proceed.
all to yourself.
Okay, the chair recognizes Mike Deneen.
Okay. I was talking briefly with Brian, and we think that it might be good for the long-term survival of the club if we have an actual officer who's responsible for finding the John Gianfortes of the world. Somebody who is as much a part of the club officially and whose role is as much a part of the club officially as the president, the vice president, the treasurer, the secretary, and so forth. Especially the way things are right now. We don't know when this is going to change. And I'm not going anywhere and I can continue doing this, but it's really completely missing from the organizational structure of the club, and it's absolutely central to the functioning of the club. So I think that needs a remedy. How we want to address it, I don't know, but it's just a heads up. We're probably going to have to take another look at the bylaws. But this should be a central position in the leaders of the club, because the whole club gets together to deal with this, and it's completely missing. There's nobody whose job it is. So people just step in, and then everybody says, oh, well, this is being taken care of, so I don't need to worry about it. I've got a lot of contacts from this club and from GAC and even some from the New Hampshire guys that I'd be glad to share with whoever we put in that role, but I think we need to make that a role. That's it. That's all I have.
All right, is there any further discussion?
We all look scolded. I didn't mean to scold people.
So do we need to propose a bylaw change?
I think what we need to do is have an officers meeting.
All right.
A board meeting.
Who are the two at-large members right now? Pardon my not remembering their names, but I've had a lot on my mind lately.
I'm one of them.
Okay, all right, good. Thank you for stepping up.
Not sure who the other one
Who
is.
is the other one?
Sal, maybe?
All right, I think that one of our first orders of business is that we need to establish who the other at-large member is,
I'm finding that out right now. Yeah.
because I think that would be very important.
You'd have to go back to the March business meeting.
Oh, it's Sal, the other guy that's with him.
You know, thinking back to the last time that I was president, and I was president for 2 years, and that was about, what was that, Ron? That was about like, what, 10 or 11 years ago, maybe? Or
Yeah.
was it more like 8 and 9 years ago?
I think it was less than that.
Yeah, I think that I only brought in a couple of speakers. One of them was, you know, New Moon Telescopes. One of them was Rob Teeter, and the other one was Ed Ting. And because basically back then we didn't have COVID to deal with, so entertainment at every night was actually stargazing, and we lucked out that just about every single night we had decent skies.
Let's have a board meeting and talk about this.
Yeah,
thing.
let's have a board meeting and talk about this. Okay, moving right along. Do we have any other old business? All right, seeing as we have no other old business, I have one item of new business that I guess I will present first. And this deals with an incident that happened last Saturday night, when I frankly thought that I was doing a nice thing. I had been doing hospital rounds on Saturday at 3 different hospitals, rounding on my patients that have compromised immune systems and chronic respiratory problems to either treat them through a COVID illness or to try to prevent them from getting COVID. And I got home. I got to the hospital around maybe 7 in the morning. I got home about 7:30 at night. I parked my car in the garage. I walked out of the garage, looked in the eastern sky, and happened to see something that I thought was really cool, which was a conjunction of a near full moon, Jupiter at 12 o'clock and Saturn at about 9 o'clock. So I snapped a picture of it with my smartphone. And then about a minute after I snapped the picture of it, I posted it on the listserver. And then I was very surprised a few hours later to have received a written complaint from a longtime member by the name of Elaine Wahlberg, no relationship to the Wahlberg brothers, I guess, who said that she was upset that she did not get more of a heads up of this conjunction event. She said that she only got a brief look at it, but if she had more of a heads up, she would have wanted to observe it with her telescope. Now, mind you, the other thing that was going on that night that Dennis was nice enough to report to the club was when we had the, the Elon Musk, orbiter separated from the International Space Station. And I'm going to ask Dennis if he would share, some of his, observations of that after we discuss this little tidbit here. But I guess the Elaine Wahlbergs of the world were upset that we don't have some method of responding the membership to non-deep sky, solar system related phenomenon, in more of a timely fashion. So I want to propose that we establish a rapid response team who could keep, abreast of, non-deep sky and solar system developments and report it to the club. And because of Elaine's great interest in this, and because she's the one who, made the complaint, I would like to propose that she be the captain of this rapid response team. Do we have any discussion?
Maybe Elaine would like to jump in.
Well, before I actually make the motion to nominate her to be captain of the rapid response team, I felt it was fair that we have some.
Yeah, please don't do that. I don't have the bandwidth for that. And I would say that characterizing what I wrote as a complaint was a little bit strong. I just said I was disappointed that I hadn't gotten more notice because I didn't get a chance to go see it. I didn't mean to make it a personal complaint against you or the club. I just was surprised and disappointed that I didn't get a chance to run outside.
Okay.
I was as tired as you are, probably, so.
All right. So would you be amenable then to letting the matter drop?
If you want to let the matter drop, or if somebody wants to volunteer to keep an eye on things of a non-deep sky nature, that would be fine. I have no problems with that.
Yeah,
I
I
have a
would
suggestion,
have
if I may.
reported about it sooner, but like I said, I was doing hospital rounds all day.
Right, and I have been looking at certain sites. Maybe there are sites that call out this stuff better on a night-to-night basis, because we have so few clear nights that trying to get something together as far as a plan to observe is pretty ridiculous, because you can't. Every time you decide you want to go look at something, it's cloudy. So, but if people know that something's coming up, they might just mention it.
I have a solution. But
Yes, what's that?
He wants to say something.
The vice
Yeah.
president, you
Well,
are recognized.
Well, I have plenty of things to hit my email box every week of upcoming events. I'd be glad to just, once a week, send that out to the listserv, saying, coming up this week, do this, do that. You can see that. You want me to do
Also-
that?
That's a great idea, but also we can, if you look at, say, the calendar on the GAC site, there's all kinds of events listed for free by combining different astronomy calendars, so that it's peppered with all sorts of non-deep sky stuff. So there's a software solution to this as well.
There's a lot of phone apps that will give you plenty of warning. I think Sky Safari or Skywalk will.
Skywalk.
I get that every
Yeah.
once a week.
Yeah.
Yeah.
But it's always, the weather never cooperates. So
The other thing is the RASC handbook has most of these conjunctions and things listed, but you have to have a copy to do it.
Yeah.
As I mentioned to Brian, somebody could probably just copy out a few of them and pass them around without violating copyright if we don't post them on the website, make them available by email or something.
Ken,
yeah,
could you send out that information on that app to the listserv?
I sure can.
Thank you.
Yep.
Thank
All right.
you very much. Okay, I would now like to call upon my very good friend Dennis Gudzovich in order to describe for us what he saw earlier on that same night with regard to the Elon Musk orbiter and the International Space Station.
Okay, basically, I actually saw a posting on it on the ATMs. And the first posting, the time was off by 2 minutes. The second posting, they corrected it. But I did catch it as it cleared the housetops and that. And the ISS was definitely bright, but you can see a little dot behind it about probably 1.5 to 2 degrees behind it, trailing along all the way across. And I just followed it all the way.
That little dot, that was our boys in the,
That was the Dragon capsule.
wow.
And that was something I had never seen, so I was thrilled to death out of that thing.
Yeah, yeah, I saw the report of that, and all I could think of was that's a, you know, that's a really cool observation. Thank you.
And I looked at it by eye, and I looked at it with binoculars. Binoculars did a little better, but beyond that, it was great just by eye.
All right, how fast would you say they were moving? In
About
terms
17,000 miles.
Yeah,
an
no,
hour.
no, no, I meant from your point of view.
My point of view, it took about 4 minutes to cross my whole field of view.
Wow. Okay, thank you, Dennis. That's great.
Ted, were you trying to lean in?
Out here in Arizona as well. But unfortunately, the monsoon clouds got in the way. I saw the space clear the horizon, and it got up about 15 degrees. At that point, I still could not see the Dragon capsule, and then the space station went behind Burbank, so I lost it. I suspect if it had been clear all the way to the zenith, I would have been able to catch both of them in binoculars. Many years ago, I saw the space shuttle chasing the ISS from New Hampshire, and that was a thrill. They were both really bright, and it was obvious one was chasing the other. But now
How big is the Dragon capsule, like, let's say, compared to an Apollo, command and service module that, those of us who are in my age bracket would, remember?
They're on the order of the same size, but nothing like the size of a shuttle.
Well, the shuttle's a lot bigger, yeah, for sure.
So it was a lot easier to see when it was chasing the ISS. But we're going to get a lot more opportunity to see the capsule chasing the ISS in the future. So plenty of opportunities for it's not a once in a lifetime kind of a thing, which is great.
Dynamite. That's fantastic. Okay. All right. Do we have any other further new business?
I just have two questions. Rick, are you going to do this?
John Hobbs for 2 questions.
Richard, are you going to send this this list around that you have?
If the club wants me to do it, I haven't heard yes or no yet.
Oh, that's what I needed to figure out. Are you going to do it? Yes or no?
I will if the club says they want me to do it.
I move that we draft Richard Lukey to send out a weekly update on non-deep sky material.
I second.
Done.
Well,
Okay.
wait a minute. Okay, now it's done.
My second thing is I want to apologize for my political rants a few weeks ago on the website. I was in a discussion with some people about those things, and I forgot where I was. And I did it on the website, and I apologize for that, and it won't happen again.
Right, I wasn't even going to bring that up because
I
that's a private matter, but that's
I'll
okay. I
apologize.
very much appreciate your apology, and thank you very much. You are a gentleman. I have proclaimed that you are a gentleman.
Okay.
Okay, but thank you very much. Just as a follow-up, I did have some brief conversations with a couple of people, and they said that they would definitely be remaining in the club, and they accepted your apology. So I think we're all good with that. So thank you again for apologizing. You are officially a gentleman.
Okay.
All right. I don't think we need any further comments on that other than to say thank you.
I'm not putting it in the minutes.
Okay. Yeah, I wouldn't even put it in the minutes. Why don't we not even?
I'm not.
That? Yeah. Okay, great. But thank you. Okay. Any other new business?
In the non-deep sky, I just want to point out tomorrow night there will be a Moon-Mars conjunction. A rise about 11:30 out here, less than a degree apart. Should be nice. Third quarter moon in Mars.
Wow.
Huge
Now,
disappointment.
I've seen Jupiter and Saturn out there, obviously, but where is Mars in relationship to Jupiter and Saturn right now?
Pretty far to the east.
Oh, okay, cool. All right, okay, that's cool. All righty, okay. So seeing as how we have gone over old business, new business, director reports, upcoming activities, treasure reports, and minutes of the last meeting, I will now call for a nomination for adjournment of the formal business meeting.
So moved.
Do I have a second?
Second.
All right, by acclamation, I am going to adjourn the business meeting, and we're going to get on to the fun part after I bang the gavel here. Okay, tonight's guest speaker, we are privileged to have with us a true friend of the North Shore Amateur Astronomy Club, whom we have had the privilege of hosting many times. And during times that we have hosted him in person, we have had some really incredible dinners at China Blossom. Okay, right? Yep, okay, China Blossom. Our good friend, John Gianforte, is the UNH Observatory Director and Associate Extension Professor in Space Science Education. And he is currently collaborating on several NASA missions, and we will hear about those and other related NASA missions, as well as some new developments in astronomy at the UNH. So without any further ado, I would like to turn the microphone over to Professor John Gianforte, our good friend, to please enlighten us on what's going on.
Okay, before we jump in, on one management note, I'm going to mute everybody in a minute, and I will unmute John, and that way there won't be any dogs barking in the background. John, you're a co-host, so just share your screen and you're cool. Your microphone is not on.
And China Blossom is #1.
Okay.
Thank you. And I was there this evening at 5:30, but nobody was there. So I had to rush home here and get ready for the meeting. I'm kind of disappointed that you guys weren't there. So what's up with that?
Are they open for inside?
Well, I was going to eat outside. I mean, so I do appreciate those and can't wait to a time when we can do that again.
They're open for curbside pickup.
Oh, there you go.
Outside there now too. We ate.
I'm not involved with several NASA missions at UNH, but UNH Space Science Center is, and I'll mention a couple of those missions in my talk toward the end. But there is one aspect that I wanted to. I'll share my screen here. Okay, so what's new astronomically at the University of New Hampshire? Well, there's a couple of, several of you, probably more than several, and certainly Ted, I'm surprised to see you, but really glad to see you here. You'll certainly appreciate this. For the longest time, members of GAC and also some members of the North Shore Amateur Astronomy Club have helped the UNH effort to do some serious outreach in the New England Fall Astronomy Festival that has taken place usually every other year since 2011. And it's been a real, it's been a successful event. We've kind of had some battles with Mother Nature, but I think we've persevered and we've found the upper hand in all of those battles, even though we got rained on a few times. But we couldn't certainly have done it without several astronomy clubs, both North Shore and GAC, as well as the New Hampshire Astronomical Society. But it's always been, it always had been a major torture to get UNH involved and actively supporting the event other than giving us the permission to use the observatory and the facilities, which we ended up having to pay for, of course. But there have been a couple developments despite the deplorable situation with COVID. And I decided that when I was deciding what to talk about tonight, I think it was worthwhile to mention some major developments at the university that have demonstrated their renewed interest in astronomy and more profoundly in education and outreach in astronomy by actually giving me a joint appointment both to the College of Engineering and Physical Science as well as to the UNH Extension, Cooperative Extension, which many of you probably have no idea what I'm talking about. So because of that, I decided to make that as the focal point of my talk tonight and talk a little bit about this new arm of support that the university has given to outreach, space outreach that we've been doing at the observatory for a long, long time. And that's since Halley's Comet came around. I've been volunteering at the observatory in one form or another. But never in my wildest dream did I realize just how many dedicated professors and staff people and other faculty are in various forms of education and outreach. And I've listed, in fact, if anybody from UNH was seeing this slide, I'd get scolded because I'm sure I don't have the right logo up there. And I've only given you 6 out of the many different areas that the UNH extension, cooperative extension arm of the university system operates, including citizen science, horticulture and agriculture, 4-H youth development, STEM education, youth and family support, community and economic development. There's a whole bunch of ways that the university and many of its faculty and staff are so dedicated to education and outreach in some of these areas. So I decided to talk a little bit about what that means and how much that will help the observatory reach more people, all of these groups. I should say most of these groups you see on the screen right now, and hopefully you can see the screen. Can you guys all see my screen?
Yes.
That will be able to reach all of the clients that all of these different areas of UNH Cooperative Extension reach. So just thousands of people, thousands more people have just been put into our ability to reach them in some of the things that we do at the observatory. And in this day and age, in this time, in the current situation, with the current administration, with the pandemic and all, outreach and education and community knitting together of the community in positive ways is of the utmost importance, as I'm sure you all agree. It's got to be a foundation of what we do with some of our time. The UNH Cooperative Extension has more than 5,000 volunteers, 160 paid staff, and they touch 36,000, more than 36,000 young adults throughout the state and beyond. And in its agricultural and 4-H programs has improved more than 150,000 acres, which was mind-blowing to me. So I'm getting to know a whole new group of associates and colleagues that is going to make the work of the observatory that much more, I guess, felt by the citizens of New Hampshire and all of northern New England. So I'm really, really happy about that. So that the next time we're able to have a New England Fall Astronomy Festival, which won't be this year, but perhaps next year, we're going to have the support that we never dreamed possible to make the event happen. And I think, and I'm not afraid at the crowds that this new wave of help will give us to make an even bigger and better imprint on the youth and families of northern New England. So, and I think Mike, and there's others that you probably know, and Ted, you know how important that is. So tonight, on tap for tonight, since some of you have already begun drinking, I thought that on tap was probably appropriate. So I'm going to talk a little bit about the observatory, just a little bit, I promise. I'm going to talk a little bit about some of the missions that have been in the news. And then I'm also going to touch upon some of the space research that is going on at UNH, mostly in the Space Science Center, which, if you know anything about the university, that takes place in Morse Hall. It's the building with the radio telescope on the top of the building. So in case, this is one of my favorite pictures of the observatory. We've added a couple new buildings. Of those of you who haven't participated in the last New England Fall Astronomy Festival back in 2018, we've added a new outbuilding. The building to the right is already too small for all of the telescopes that have been donated to the university and to the observatory. We're already outgrowing that one. And I also want to mention that I'm about to pick up an 18-inch Dobsonian telescope that a family in New Hampshire wants to donate. So we're going to have a huge point of attraction for our next New England Fall Astronomy Festival when that happens, hopefully next fall. So at the risk, because I visited and spoken to this club before, I don't want to repeat lots of things that I might have said before, but basically this is the mission statement of the observatory. Not only are we supposed to provide a quality laboratory for research for students, faculty, and staff, but we're also supposed to provide a unique educational experience to all of the UNH community, as well as people all over the state and in the New England region, northern New England region. So it isn't just New Hampshire residents, it's covers a much wider geographic area than just New Hampshire. But education outreach and providing research opportunities are the prime directives for the university and our staff. Who uses the observatory? We have 2 courses right now that make regular use of the observatory in at least 3 semesters during the year, but there are several other physics and other courses that make at least 1 visit to the observatory to expose their students to this resource that unfortunately very few students know that we have. We have a general introduction to modern astronomy class that I've been teaching the last few years. That's a high enrollment course between 150 and 170 students per semester. We have our labs out at the observatory. I teach an experimental physics class that involves senior physics students and grad students. And I teach the astrophysics section of that experimental physics class, where the students do 3 major labs in the fall semester of each year. And included in that is one of those labs is an exoplanet lab. Our Physics 795 class is an independent study in physics course. And last year I had 3 students do exoplanet independent studies out at the observatory, which was great. Any professor, any head of any organization on the university campus, and that includes the Concord and Manchester campuses, can request a visit to the observatory, and we'll accommodate them with an active presentation, hopefully on a clear and nice night to observe. Like I said, any organization on campus at all can visit the observatory and get support. Although the observatory is currently closed to the public and to students, we're already formulating plans to reopen the observatory on a proper distancing motif as we try to reopen, because we're getting a lot of emails from people who want to visit the observatory. So we've been doing a lot of live streaming virtual observatory sessions to our Facebook page, which have been very popular. So we haven't been doing school groups, scout groups, or church groups, simply because the observatory has been closed since spring break, which was approximately March 18th of this year. So we're, like I said, we're making progress on plans to reopen, but right now we're still closed to the public. Hey, Michael, would you keep an eye on the chat in case anybody has questions? Because I don't want to go on continuously without answering questions if somebody has them.
Absolutely.
Thanks. All right, so just a couple of, if you've never visited the observatory, hopefully you can do that again, hopefully this fall. A couple of images that we've taken when we've had school groups out there before all this started. Ted, you'll remember Big Bertha that you worked to restore to working condition. This is a picture is a little bit old because it's before we had the concrete ramps poured, which makes rolling this big, massive 12.5-inch Newtonian reflector out of the shed much, much easier. And it is still one of our best visual instruments for observing the moon and deep sky objects. Here's our central instrument, is a 14-inch C14 old orange tube design on a Paramount MX Plus mount. Okay, so the research that we do at the observatory and the folks of the North Shore Club know that we've been doing exoplanet work, because I gave a talk on exoplanet work back some time ago, so I won't go through any of those slides. Although I will point out that as of right now, there have been 4,300 exoplanets that have been confirmed in 3,176 planetary systems, which is just amazing, all from November of 1995. And 703 of those systems are multiple planetary systems. So this is my major research area that I'm interested and involved with right now, is exoplanets, as many of you know. So since I gave a talk on transiting exoplanets, I'm going to skip some of these slides, although I'm going to go through a couple of them in case they bring up any questions about this, because this is one area where amateurs are playing an increasingly important role in contributions to astronomy, is exoplanet transit observations. And these, you probably will recognize this slide, at least part of it. It's a slide I showed, why would we want to look at transits? And transits is only one of the methods that we can detect planets orbiting other stars in. But I added working on detecting transit timing variations. As planets orbit a parent star, and if the Earth is aligned in such a way that when the planet transits across its parent star, it blocks some of that light from the star as viewed from Earth, we see that as an eclipse or a transit. And if the planet is a sole planet, the only planet in a system, the transits occur at very, very, very regular intervals. The durations of those transits are fairly constant and repeatable over months and years. However, if there are other planets orbiting in the system, even those that haven't been detected, those planets that haven't been detected, or maybe those that have been detected as well, can influence the motion of a transiting planet so that the repeatability of the transits are disturbed, as is the length or the start time or the mid-transit time of these events are out of kilter, as evidenced by an additional planet orbiting either closer to the star or further from the star than the planet we know about. And this is the area that, as many of you know, I'm in a PhD program right now, and am just in the process of selecting stars from the TESS satellite, the Transiting Exoplanet Survey satellite, to begin my work on determining and looking for these transit timing variations. And it's some of the most interesting work I've ever been involved with in astronomy. It's just amazing opportunity to do new cutting research with a satellite that NASA put up in space that actually needs help from ground-based observatories with telescopes that don't need to be very big, which is just mind-blowing to me. So I did want to mention that we're doing this kind of work at the UNH Observatory. And here are some transit curves that I've been involved with over the last few years. I'll just go through these quickly. Each one of these little diamonds on these plots is an observation where a brightness measurement of the parent star was taken before or during a transit or after the transit to see the evidence of the eclipsing or transiting planet. One of my favorite transit targets right here is Trace 1b. I'll go through these quickly. And I love this picture. It's an early picture of Kepler when the Kepler probe was actively working. One of the mission investigators produced this little graphic of some of the planets that the Kepler mission actually detected, and to scale in comparison to its parent star. And you'll see that there are several multiple planet systems there. And this is what Jupiter would look like transiting across the disk of our sun right here. So you can see that it does block quite a bit of the sun's light. Okay, so I'll stop here and see if anyone has any questions about that. But if not, I'll just give you a second to formulate a question. And if you don't have them, I'll get right to the meat of the talk.
John, some of the planets on that last Kepler slide were incredibly tiny.
Yeah.
Are they still within the ability? Well, they were within Kepler's ability, obviously. How big would a planet have to be transiting this star before you or I could see it in like a C14?
Well, so who is that? Ted? Who asked that question?
Yes.
So that's a great question, and this is one of the things that amazed me. We can detect, and of course, all depends on the aperture of your telescope, right? The bigger, theoretically, the bigger the better, right? The more light gathering capability you have, the fainter a star you can see, which opens up a lot more target star systems, right? If you can see faint 13th or 14th, 15th magnitude stars, that gives you more potential transiting systems to study. But we can detect as low as a 1% degradation in light with a relatively small telescope, say 8 to 14, 16 inches in diameter. So 1% is not very big, but it all is dependent on the size of the planet versus the size of the star. It's just the area of the planet versus the area of the star. So a lot of exoplanet folks in the exoplanet field are making, including a lot of their targets as M-type stars. Cool, very small, low luminosity, red stars, because their masses are maybe a tenth to a little more than a third of the sun. So it's easier for a planet to cause a gravitational wobble in a light star than it is in a heavy star. And for those scientists that are using the radial velocity technique or the wobble technique, it makes these M-dwarf planets very attractive targets. So here we're not looking at the amount of light blocked by a planet. We're looking at the perturbations in the motion of a star, if you will, induced by the gravity of the planet. That's the radial velocity technique. But when we're talking, so it's really, really important to be able to characterize the star, because we're looking at planets, we're looking for planets that are now getting below, much below the size of Neptune, when at first all we were finding were Jupiter-sized planets and larger. For the first several years after the first exoplanet was discovered orbiting a sun-like star in November of '95, all we were finding were these hot Jupiters, these planets that were the size of Jupiter and bigger, orbiting so close to their star where they were making one complete orbit in a matter of like 1 to 6 or 7 days. So hot Jupiter is probably an understatement, right? Orbiting that close to your parent star. But now we're able to detect. I mean, Kepler was detecting planets that were Earth-size using the transit technique. Now we're not that good yet with ground-based instruments, but we're catching up quite rapidly. And our detection and our computer software that analyzes the data that we collect from small to mid-sized telescopes can really detect getting down there to pretty small planets. I have access to an array of 17-inch, 20-inch telescopes in Australia. And so there's 3 locations, one in Kentucky, and one in Arizona, and one in Mount Kent in Australia, that is doing, all working together, doing photometric and radial velocity measurements for detecting exoplanets. So, and to tell you the truth, we're as interested in characterizing the star as we are the planets, because right now, the size of the planets that we're able to detect is getting so small that the pulsations, the physical and luminosity pulsations of stars are now a source of noise in trying to discern what's a planetary signal and what's just the star sneezing or pulsating slightly in size. Can actually mimic a planet orbiting the star. So we're able to detect, you know, sub-Neptune sized planets right now, and this is getting smaller and smaller. All right, so I'll talk about a couple of space missions. Probably the one closest to everyone's mind. Sorry, I forgot the 0 on the Mars 2020 rover, better known as the Perseverance rover and the Ingenuity helicopter, which I think are 2 great names. This is an artist's conception of the Perseverance rover. It's modeled and it's very similar to the Curiosity rover, which landed on Mars in August of 2012 and is still roving around on the red planet doing groundbreaking research. But I thought it would be interesting. The white area, the white sites are possible. They were candidate sites for Perseverance, but the scientists settled on the Jezero crater, which is in red on this diagram. But it also includes locations of the Phoenix probe, which was a lander, the Viking 1 and 2 probes that landed in '76. Pathfinder 97, and Spirit and Opportunity, which landed in 2004, and the Gale crater, which is where Curiosity is. So this is kind of where we've got Mars covered right now. And when Perseverance lands in February of 2021, it's going to land on the Jezero crater. and this is the landing site right here. This little picture down here, this is a blow up of the area, but the landing site is really, really small right here. And it happens to be about right here. This peak right here, where my arrow is this peak right over here. So the landing site is right in this area right here. And why there, you ask? Because it's the Mars Reconnaissance Orbiter data suggests that sediments deposited here in the deltas from this ancient riverbed contain minerals that indicate chemical alteration by water. And it's always been, if we follow the water, maybe we can find past life. We don't expect any life on the surface of Mars right now, but perhaps we can find fossils or indicated past habitability in some of these areas where once were very wet. So there's also an assortment of carbonates and clays, which the Curiosity rover has actually found organic compounds in. Remember, there's no organics on the surface of Mars because it has no shield against ultraviolet radiation from the sun because it doesn't have an ozone layer. So we don't expect any life, at least carbon-based life on the surface, because it's basically sterilized from UV from the sun. So that's where it's going to land in February. It's going to use the sky crane maneuver, which is what Curiosity utilized when it landed. A helicopter on Mars, can they do that? It just seems bizarre. It just seems out of science fiction that a helicopter on its way to Mars that'll land in a short period of time. And if it does, 5 flights are planned for this small compact helicopter, which will be the first airborne craft to fly on another planet. Oh, this is a note to myself. I'm going to play this video, hopefully. Let's see. Oops.
You know, Mars is the closest place that we can reach with robotic exploration that we think had a really good chance of having ancient life.
The Perseverance rover will land at a location called Jezero Crater. Jezero Crater is a very interesting place. It's a crater that once held a lake.
There are a lot of craters on the surface of Mars that could have once hosted ancient lakes, but not every crater that we think had a lake actually preserves evidence that that lake was there.
It had an inflow channel and it had an outflow channel. That means it was filled. The crater was filled with water.
In Jezero, we have probably one of the most beautifully preserved delta deposits on Mars in that crater.
This is a wonderful place to live for microorganisms, and it is also a wonderful place for those microorganisms to be preserved so that we can find them now so many billions of years later.
There is no other place on Mars that has the unique combination of a lake setting, a beautifully preserved delta, and the diverse mineralogy that we have in Jezero Crater. So it's truly a special landing site.
The major goal of the Perseverance mission is to investigate astrobiology on Mars, and in particular, to address the question of whether life ever existed on Mars. The Perseverance rover starts with a design that's very similar to Curiosity, but we've added to it a whole new set of science instruments. And these science instruments were purposefully selected to help us in the search for biosignatures.
We're going to be taking microphones with us. For the first time, we're going to have that human sense on another planet.
Perseverance carries with her a grand experiment in spacefaring technology, a helicopter, the name of which is now Ingenuity.
One of the major upgrades that Perseverance has from Curiosity is that it's able to self-drive for a distance of up to 200 meters per day. As the rover is driving, it's literally building the map of the road it's driving on Mars.
Scientists for years have told us that to really unlock the secrets of Mars, we have to bring samples from Mars back to Earth.
So what Mars 2020 is going to do is to drill samples, put them in small tubes. We're going to seal it in its own individual tube. We set them on the surface to provide a target for the second two missions, which hopefully will get in development in the next several years and could potentially get the samples back to Earth by 2031.
Perseverance is a very, very profound first step in both our understanding of our place in the universe and a stepping stone towards human exploration of Mars.
That just gives you a small piece of what's going on with Mars exploration. And as you probably already know, United Arab Emirates and China also launched probes to Mars this July. The ESA mission was delayed because of COVID, but we're sure that when that gets on track again, that'll be another mission that will be launched probably in 2 years at the next launch window. All right. So Juno, not a new mission, but lots of new results coming in from this probe that arrived at Jupiter on the 4th of July back in 2016. This mission is to characterize Jupiter, and it is doing some rather strange things. It is on a very long 53-day mission that brings it in very close, only a few thousand miles above the cloud tops of Jupiter, and then jets it right back out at a very great distance from Jupiter to get it out of the radiation fields that Jupiter has, and to extend the life of the spacecraft. And the mission has been very, very successful over the last few years with some pretty interesting results. One of the results is some very strange magnetic anomalies, including this great blue spot that seems to be altering Jupiter's magnetic field. Never before, we never had a probe with such instrumentation that could actually probe Jupiter's magnetic field, all in trying to solve one of the biggest questions as to whether Jupiter and the other gas giant planets have solid rocky cores at their center. That question is still unanswered, but understanding the magnetic field of Jupiter will help us to try to figure out the answer to that question. You've undoubtedly seen the JunoCam images, which is the only visible light camera on the spacecraft, which wasn't expected to be a science instrument at all. But the general public has access to the raw images taken by the JunoCam and has uncovered some really dynamic features in Jupiter's atmosphere, including hurricanes, very active weather systems at the south pole of Jupiter. So the Juno spacecraft is actually orbiting over the poles of Jupiter, which has given us our first look at the north and south poles of this gas giant planet. Another thing that it's told us, it's helped us shore up information about Jupiter's internal structure. We used to think that these cloud belts, like the north and south equatorial belts that you see when you look at Jupiter in your telescopes, we thought that they were just skin deep. We only thought that they were very, very close to the surface. But we're finding out now that they go much, much deeper into Jupiter's atmosphere than we once thought. And they carry water and ammonia deep down into Jupiter's atmosphere, much deeper than we thought. In fact, there's very, very powerful lightning bolts and rather large hailstones made out of water and ammonia hailstones that are as big as softballs. If you take a look at the pressure gradient, take a look here. At a depth of about 100 kilometers, about 60 miles. The pressure is about 12 times the atmospheric pressure at sea level on Earth. But at 600 kilometers, it's 1,000 bars. And at 1,000 kilometers, about 620 miles, it's 5,000 times the atmospheric pressure at Earth. So you can imagine what it's like at the center of Jupiter. So this is these are some of the things that Juno has revealed to us over the past few years. I think it's made its fifth, I forgot how many close passes it's made, but every time it makes a close pass, there's a data dump that we get on Earth about what it's uncovered during the last encounter of the planet. So in case you haven't seen these, I've given you some web links. Just Google Juno, NASA's Juno probe, and you will see some of the most spectacular artistic images of the largest planet in our solar system. It really makes you appreciate planetary science. Another Mars mission that launched a couple years ago, arrived at Mars back in November of 2018, is the Mars InSight spacecraft. And this is the first picture that if you watch the spacecraft land, within minutes of it landing, they actually showed you the lens cover was still on the lens, but it took a picture right through the lens cover that was covered with dust. A very successful mission. And the primary mission is to study Mars's interior. What's going on underneath Mars, beneath the surface? And the goal is to measure the heat flowing out of Mars and to see if there's any Mars quakes taking place on Mars. And here's a much clearer picture from one of its cameras. Here's a photograph here. This is not powered by RTG, it's powered by two solar panels. So some of the results so far since landing. So we, in fact, the textbook that I'm using right now it still says that Mars is a geologically dead planet. But ever since we landed Mars InSight on Mars, we've measured more than 450 seismic events on Mars. So we know that Mars is still geologically active world, somewhere between the activity level of the moon and the activity level of the Earth. So despite having its core that cooled down about 3 billion years ago, and it solidified, therefore lost its global-wide magnetic field, Mars is still at least somewhat geologically active. We've also found the scientists collecting this data on the magnetic field is more than 10 times stronger than originally estimated from orbital measurements. It doesn't have a planetary magnetic field like the Earth does, because its core is solidified. So in order for a planet to have a planetary magnetic field, it has to have rapid rotation, which Mars does, but it has to have a semi-molten conducting core, and it doesn't. But the surface remembers the previous magnetic field from more than 3 billion years ago, and some of the local magnetic fields that are measured on Mars now are much stronger than they originally were thought to be when measured from orbit. Atmospheric measurements reveal a much more dynamic atmosphere than we first thought. Remember, Mars's atmosphere is only 1% as dense as Earth's atmosphere. So it makes it pretty low atmospheric pressure, but it's still, even though it's that atmospheric pressure is that low, the weather systems on Mars are very complex. And if we're going to be sending people to Mars, we've got to understand the global atmospheric conditions on Mars so we can protect the robotic and the human participants in missions that'll be going to Mars in the next 10 or 20 years. You've probably heard about the mole, which was supposed to dig several meters into the Martian soil and measure heat flow from deep inside the planet. Well, that's been somewhat of a pain. It hasn't worked properly, and the reason that it hasn't worked is that the project engineers tell the scientists that there isn't enough friction with the Martian soil, and the penetration ability of the mole depended on a certain amount of friction so that it could go deeper and deeper into the soil. But right now, it's only managed to get down about 15 centimeters below the surface, which is not nearly as deep as they wanted to go. So that's been somewhat of a hindrance. The TESS mission, the Transiting Exoplanet Survey Satellite, that was launched in April of 2018 aboard a SpaceX Falcon rocket, is up and running, and has been a very successful successor to the Kepler mission, which stopped operating officially in October of 2018. And its mission is to survey 200,000 of the brightest and closest stars to the sun. As of yesterday, it has tallied 66 new planet conformations and 2,100 identifications of planetary candidates. Now, here's the interesting part. As opposed to Kepler, which looked at the same patch of sky for almost 3 years, a 10 degree by 10 degree patch of sky near the Cygnus-Lyra border, TESS is a survey satellite where it looks at the same piece of sky for about 27 days and then it moves on. And it's currently surveying the southern hemisphere skies right now. So this means that the candidates that TESS uncovers require ground-based follow-up by ground-based observatories. And this is actually where I'm getting candidates for my PhD project, is from the TESS mission. And the TESS mission is conducted through MIT, right close by to us. So that's amazing that we have MIT, close by academic institution, conducting this important exoplanet mission. Right, not 50 miles from us. Okay, the Parker Solar Probe is a mission that launched also in 2018, and first encounter date with the sun was later that year, just a couple of months later. And this satellite is supposed to get within about 6 million kilometers from the sun, which is the closest any spacecraft has ever gotten to the sun and lived to tell about it. And this is one of the NASA missions that UNH is participating in. And one of the key, we have a lot of researchers studying the sun, the magnetosphere of the sun, and the heliosphere of the sun, and the solar wind's influence on the solar system and into interplanetary space. So we have a lot of researchers studying that aspect of what we call space science. But there are some researchers that are looking very closely at the sun to see how the sun generates these energetic outbursts, these solar flares that can be very dangerous in terms of their radiation to people on the International Space Station, and especially people who are leaving the Earth's magnetic field behind, which kind of protects us from the sun's solar wind. So if you're in a mission headed for Mars, which is a long transit time and return time, you're subject to the sun's whims and temper tantrums. So the better we understand how the sun produces this radiation and what signs we can read from the sun, we can help protect people traveling on interplanetary missions. So that's one of the most important aspects. UNH has an instrument on this Parker Solar Probe that's going to study both low and high energy radiation from the sun. That's the name of the instrument. Interstellar Boundary, or that's the IBEX probe. It's the Integrated Science Investigation of the Sun instrument that's aboard the Parker Solar Probe. So I want to get to this video here. This is a short video I thought would be interesting.
Traveling through the sun's blazing hot atmosphere, NASA's Parker Solar Probe has sent back a complex, close-up view of our star. The spacecraft confirmed that our picture of the sun from Earth is deceptively simple. Parker is the closest spacecraft to the sun, meaning we now have never-before-seen details about the solar wind and solar energetic particles. Solar energetic particles are high-energy particles that can endanger both astronauts and satellites in space. The solar wind is the continuous outflow of particles and magnetic field from the sun. Both speed out, filling up space, and affecting space weather throughout our solar system. For the first time ever, we were able to go to the source of the solar wind and solar particles. Here are 5 features Parker saw. We've long known that space is full of cosmic dust. We can even see the dust from Earth because it reflects sunlight. Parker saw evidence that the dust stops at an estimated 3.5 million miles from the sun. As the dust gets closer, the sun vaporizes it, creating a dust-free zone surrounding the star. At Earth, it appears that the magnetic field lines flow evenly out from the sun, but Parker saw them behave in a surprising way. The magnetic field lines flip in a whip-like motion, turning 180 degrees around in a matter of seconds. These switchbacks came in clusters and were timed with fast-moving clumps of plasma in the solar wind. Scientists have long wondered if the solar wind is generated as a continuous flow or in spurts. We now see evidence that the solar wind has rough, irregular texture. The plasma within it also seems to lack an orderly sense of direction. Some clumps of solar material fire out into space, while others fall back toward the sun. These clumps may be distorting the magnetic field, causing the switchbacks. They may also be an indicator of what the solar wind looks like in its early stages after its birth on the sun. Parker found a transition point in the solar wind. The corona is the sun's faint, outermost layer that transitions to the solar wind. Before Parker, scientists knew that the corona rotates with the visible surface below it, but they didn't know how or where the solar wind switched to flowing straight by the time it reaches Earth. Parker has finally spotted signs of this transition, and the changeover happened significantly farther out than expected. Although the sun has been very quiet over the first 2 orbits, Parker observed several tiny bursts of solar energetic particles. While these events have been seen before, never ones this small. The fast-moving particles from these modest bursts spread out as they move from the sun, making them undetectable from Earth. Without Parker's front row seat, we would never know that the sun is regularly producing these small-scale events. Fast-moving particles are a source of dangerous radiation. The more we learn about these eruptions, the better we can protect our technology and astronauts. Parker still has more work to do, but it's already helping us see our star in a whole new light.
Now, as you know, the sun's in a solar minimum right now, and the next solar cycle, cycle 25, is just starting. So Parker, the Parker Solar Probe is in an excellent position to see the transition from low solar activity to much higher solar activity in the next 2 or 3 years. So that's a big interest in scientists studying the sun. The Crater mission, which is it's called the Cosmic Ray Telescope for the Effects of Radiation, that's on board the Lunar Reconnaissance Orbiter. This mission has been orbiting the moon for a long time, more than 12 years actually. But the Crater instrument is measuring the effects of radiation at the moon, so that when humans return to the moon, as is being discussed by several countries right now, we have a better idea of what they can expect when they build these long-term habitability zones near the south pole of the moon. So this research into the radiation environment at the moon is even more important now than it was in the past. And now with an instrument at the moon, we can measure radiation levels on a daily basis on the moon's surface. So we have several professors and research scientists involved with the Crater mission right now, Crater instrument. All right, so I wanted to mention a couple of things. There was a brief conversation about Comet Neowise. If you wanted to know where it was tonight, this is a SkyX graphic that I got from my computer. Everybody's been using the Big Dipper as a focal point on how to find the comet, and it's kind of been on a path that took it from beneath the bowl of the Big Dipper on this path that's taken it to the west. It's pretty low in the sky right now, so unless you have a pretty good view close to the horizon in the northwest sky, you're going to be out of luck to see it. The perihelion date was the 3rd of July when it came as close as 27 million miles to the sun. That's pretty close. So there was a question whether the comet was going to survive, but luckily for us, it did, and it made it out around the sun, and it was even better after the perihelion. Made its closest approach to Earth not too long ago on the 22nd, but it was a whopping 64 million miles from Earth. So it's pretty far. That's about 2 times the distance that Halley's Comet was from Earth when it last returned to the inner solar system in 1986. And it was a dismal performance at 39 million miles. And that was a pretty successfully observed comet in the past. So has a relatively large nucleus, about 3 miles. So that combined with a close proximity to the sun made this comet kind of what we were looking for, and I think kind of what we all needed. I included a couple of images that I took. For the first couple of days in July, it was visible in the early morning northeastern sky, and I braved the mosquitoes and the really hazy weather we had to get a glimpse of it just barely above the horizon. This is just with a, I know it's hard to see. You probably can't even see it on your computer screens. But here it is just with a 200 millimeter lens and a very short exposure. It was in such a bright sky that I couldn't expose it for anything longer than that. The second morning that I was able to find it, I got it a little bit higher in the sky with a little bit earlier, and you can see it a little bit more clearly here. But it just whet my appetite, and I knew later in July when it was visible in the evening northwestern sky, we'd have a better chance. But after Comet Swan and Comet Atlas, I think we were all ready for a comet that was at least, you know, worth the fight to go and find it, given how close to the horizon it was. So here's a couple of shots. Like I said, 3's a charm. These are photographs taken in, I think, the 10th and 11th of July from my backyard. You can still see, still pretty close to the trees, but managed to get a couple of shots of it before the trees gobbled it up. Let's see, I think I have one more picture here. And these were the 18th and the 24th. This was taken on the 18th, and these two were taken on the July 24th from my backyard, which has trees all around it. Just happened to be a little bit of a valley to the northwest, so I was able to get a couple of good shots, but none of them in a dark sky. So that was a nice attraction and a nice break from the duds that we were watching. At least from a bright comet standpoint, both Atlas and Swan were fun to watch as they changed and as they disintegrated, but they weren't anything what we thought they would be earlier in the year. So even though the observatory is closed to the public, I've been kind of practicing using some new equipment that we've got at the observatory, been working on some planetary imaging, been shooting the moon. I love this picture of the straight wall here. And also on the 12th, back on the 12th of June, the sun was really active, no sunspots, but plenty of prominences. And I think I have a bigger picture of these. I was really surprised to see this, this beautiful solar prominence complex back on the 12th of June, which was kind of a, I don't know, kind of a foreshadowing of more active times. Right now we have 2 active sunspot groups on the sun, both from cycle 25. So that's encouraging that we're going to be seeing some increased solar activity. That's a full frame of that. So there were lots of nice prominences visible on that day. This is a picture of the Lunar Apennine Mountains. Probably recognize those for those of you that's like to study the moon. And there's a blow up of that straight wall pictured near the first quarter moon. And this is a recent effort that I got of Jupiter back on the 31st of July. It was a great red spot was transiting, and there was a satellite shadow that's just off the disk of the planet right now. So we got some new equipment at the observatory that I'm trying to perfect and utilize for our live streams that we're going to be doing more of while the observatory is still closed. I think that's my last slide. Okay, so.
Describe that new equipment a little bit.
Pardon me?
Can you describe that new equipment a little bit for us?
Yeah, one of the things that we got was an Altair GAC 360 CMOS camera. And it's built by a company that I wasn't familiar with. It's a British company, a UK company, I should say. And I was really after, I had been given some good advice from a colleague of mine at the McDonald Observatory in Texas, that he had some really good luck with ZWO cameras. They're built in China. And I wanted to get one of those for the observatory and try it out because I wanted something for planetary imaging, something updated. And they had such long lead times. Apparently, these equipment manufacturers are doing really well this year. And the lead times, they couldn't even give me a date when it would be available. This was back at the beginning of the summer, like April, May time frame. So I got this Altair camera, and it is just a joy to use, and very easy, and takes really great pictures. It's a non-cooled CMOS camera, and it's great for lunar, solar, and planetary imaging. Not so good for deep sky because it has really small pixels. So anything that's not really bright, it has a little bit of trouble with. But you can bin it 2x2 if you want to increase the pixel size. But I've only used it for planetary imaging. I've probably used it about a dozen times, and I'm thrilled with the images that it's taking. I'm really happy with them. So that's the main new pieces of equipment that that we've got at the observatory that we're going to use specifically for our live streams of the sky. Instead of just talking and chatting about what's going on in the sky, we're actually going to show things through the observatory. We're going to either stream them to our Facebook page, which we've done, or a YouTube channel. We haven't decided exactly what we're going to use. I guess it depends on what kind of software. If we broadcast to the Facebook channel, we can use Zoom, which the university has a license for, and we can directly pipe that to the Facebook page, which has been pretty successful. Yeah.
Is the Altair camera a mono or one-shot color or what?
It's color camera.
It's color camera.
It's a color camera. Yep. Yeah. Yeah. I opted for the color because I have a Skynex that I use for black and white planetary imaging, but black and white images, although monochrome cameras are much more sensitive, and what I would prefer for any kind of research application, when you're trying to wow the public, a hydrogen alpha image of the sun in black and white just doesn't do it like a nice red or orange image does.
Yeah.
And plus the moon in the various phases does show quite a bit of color, especially when you can catch it during an eclipse. So I opted for the less sensitive color camera, just so we can capture the pretty colors of the planets. Like I can't wait for October when Mars is going to reach opposition, because I've taken some preliminary shots with the camera now, and it already shows Mars a deep red color, and already starting to show polar caps, which was really good. I thought that was great. So that's the main. We're not planning on doing any research with this camera, but it's going to really help in our outreach efforts. One thing I will say about the Altair camera, the file sizes are enormous. I had to buy a 10 terabyte drive just to hold the images for more than 6 or 7 months, because it's just huge. I've been taking so many video images of the planets, but not all those are keepers, obviously. But that's a good piece of equipment. I would highly recommend it if you're interested in planetary imaging, or if you're like images of the. I would show you more movies, but I'm doing this on my Mac computer because it has a better webcam. But I was going to originally do this on my Dell, which all the images are stored on and hooked up to the 10 terabyte drive, external hard drive. But it's a great camera. If you like shooting the planets, I'm really thrilled with it. And it comes with software to operate the camera. And you get, let's see, CapSharp. It also gives you a 1-year license for a program called CapSharp, which is an even more sophisticated camera program, which is really fantastic. But the software that comes with the Altair camera is great. It works better on a Windows machine, because on a Windows machine you can store the videos in several different formats. But on a Mac, the software isn't as robust, and you can only store it in an MP4 format. So that was a disadvantage for me. But I have I can run the camera on both of these both computers, which is good, depending if I'm doing something for school or for myself.
The GAC listserv has been just on fire with CMOS this and CMOS that, and it's quite a technological shift.
Everybody seems to like them better than the old CCD cameras.
Well, the CCD cameras they have a lot of advantages. I mean, if you're doing research, I mean, the CCD imaging cameras are certainly the way to go. If you're doing anything with exoplanets, which has been my research area since 2004, and I have a telescope that has a dedicated SBIG camera hooked up to it that I never take off. And if there's something pretty in the sky that I think my students would be interested in, or I want to take a pretty picture of, I just use a very small refractor that I have piggybacked onto my 11-inch. Or if I really get serious, I'll go to the UNH Observatory and use their 14-inch. But CMOS cameras are really, really improving, and they do. I mean, I don't have time to process images, and the pictures that I get off Altair are just, some of those are just raw images that you're looked at. And the fact that it can take video images in the AVI format, which is what Registax likes. So if you like to stack your images, you can have a ball with it. It's really, and where I'm shooting is pretty bad skies, right? We're 20 meters above sea level, and any kind of if the humidity is above 60%, we're always constantly fighting, ground fog and really, really heavy air mass low to the horizon, which is a real pain in the neck. Not like some people I know who are out in Arizona where the humidity gets above 35%. That's high, right? Right, Ted? So, I mean, you put a little bit of altitude with you, this camera could really do some damage, I think. And it wasn't that expensive. It was 300, it was 300, it was like $360 for the camera. So I was really happy with the performance of it. And like I said, it's a CMOS camera. And they have other cameras. They have a very wide product line with bigger pixels, with smaller pixels. Some of them are much more expensive. Some of them are much less expensive.
They're cooled.
These aren't cooled.
No, but some of the
Yeah,
cameras are
yeah.
cooled.
The CCD cameras are all cooled, and in order to take good quality images, you've got to reduce noise. So for every 6 degrees Celsius, you cool your camera, you cut your noise in half. So if you can reduce, 10 degrees, you're really cutting a lot of noise out of your images. And when you're looking at, you're looking at a less than 1% light dimming of a star in exoplanet work, you need every trick in the book to get good data. Yeah, exactly. But as far as for planetary work, the Altair stuff works pretty good. So does their software, which I was really surprised. Let's see. What other questions? Any other questions? Now that I can see the chat bar.
I didn't see anything new come across.
Yep, okay.
All right, well, thank you, John.
You're welcome.
We really appreciate you doing this for us. Thank you.
My pleasure.
Thank you.
My pleasure. It's good to see everybody again. Good to
Thank you. Yep.
Let me take just a minute at the end of the meeting here to invite John and everybody else to the GAC meeting next Friday, where we have an unsavory character speaking to us about a doubtful proposition, but we'll see what we can get out of him. Ted's going to talk to us about gravitational waves, and we're all really looking forward to that. And until we get a vaccine, or at least maybe even past that, I think what we're going to do is invite all of NSAAC to the GAC stuff and invite all of GAC to the NSAAC stuff, so that everybody gets 2 shows a month instead of 1.
Did you say that really fast?
No, I can't even say it again slowly. All right, but so we hope everybody will come to that. We've got plenty of room on the Zoom license.
Yeah, thank God for Zoom, huh?
Oh, thank goodness, yeah. We'd be stuck using Blackboard or some other kind of nonsense.
So will the invite for that GAC meeting go out to our list server?
Yes, it will.
Excellent. Great.
And it's exactly like this. If there's a Zoom link, and you'll know your way around.
Great idea.
All right, and John, I'm gonna copy you on that.
Yep, please do.
It's probably going to be a really good presentation.
Yep, I'm sure.
Ted wax eloquent in some years now, I don't think.
Yep, it sounds like it's going to be a good meeting.
All right. Well, thank you again, John, for a really good presentation. I'm really surprised at the amount of stuff you're stepping in up there with your new work, and congratulations on the doctoral work. Good luck to you.
Thanks. I'll need it.
All right. Brian, he's still there?
He's muted.
Unmute.
Well, I'm waiting for him to step up and end the evening.
Yeah. Hello, can you hear me?
Yes.
Yeah, speak up. Speak up.
Yeah, hello.
Hello.
Hang on. Hello.
Hello.
Yeah, thank you, John. That was a marvelous presentation.
You're welcome, Brian.
And we want to get you back to China Blossom as soon as possible.
Okay, I'll look forward to that.
All right. Good night, everybody.
Good night. Take care, everybody.
Night.
Take care. Stay safe.
See you all.
And remember that astronomy is a sport that can be enjoyed by the whole family, and patronize your local observatory.
We'll all try
You're
to
here.
I'm
Good
leaving.
night.
All right.